Hello guys, welcome to my channel. This is Java data structure and algorithm course. Today's topic is implementation of generic sorted linked list. What is generic programming? Java included support for writing generic classes in Java to SE 5.0 or JDK 1.5 version. The generic framework allows us to define a class in terms of a set of parameters that can be used as a type of declared variables, parameters, and return types within the class. Before Java SE5, generic programming was heavily dependent upon the Java object class, that is the root of hierarchy in Java programming language. Example, public class, my class, and this is how we enter parameter in the class. This is a generic class that can be instantiated with any class type such as integer, string, and double. Features or properties of sorted linked list. This is a simple data structure. It uses dynamic memory allocation, allows the use of the memory only needed to store the elements within the list. The complexity of the memory is O(n). N is the number of elements stored within the linked list. It is a linear container or data structure. Linear traversal to access any arbitrary element, and cost is O(n). Cost is also O(1) if the element exists at the front of the linked list. Elements are stored in ascending order of the elements. Efficient addition and removal, where the best case is O(n), that happens at the head node or the front of the linked list. The worst and average cases will be O(n). It is a forward traversal. We can also implement backward traversal, but that is very costly because we only maintain a single reference to the next node of the linked list. Thank you guys. Let's begin coding. Hello guys, I have created project in NetBeans. So far these are just empty files. Number one is order linked list, node class, and the test class. Let's begin with the node class first. This class will maintain the data and the link to the next node in the sorted linked list. So what we will do, not just use this. This is good enough for implementing generic linked list. To implement a sorted linked list, we needed to have some kind of sorting algorithm. For example, we can use a T extends comparable. This comparable interface. Now, any object, any class that has implemented the comparable interface, we can use that into this class as a parameter. So, why we need this? So that we can compare the values of the objects stored within this node and to maintain the order within the linked list. So, the fields, instance fields, rest of the things are same, private T data and private node T and let's say next, and rest of the things we are going to implement the same, public node and T data. This dot data is equal to data and this dot next is equal to null because it is instantiate node object. Okay, simply create getter and setter methods. So insert code and select getter and setters and select both the fields and we are good to go, and that's it. Over. Getter and setter method for both the data types are generated. So let's go into linked list class. So this is our ordered linked list, and we use same T extends comparable T, and here head of the node or head of the list private node T is equal to head. Okay, first public ordered list, and we create an empty ordered list using this constructor to create empty list. This dot head is equal to null. So next we need a function. Let's write the prototypes. Public void add t data function to add an element into the list at a correct position to maintain the order of the list. Okay, helper function public void add first and t data. There are two situations that we suppose to insert at the front of the linked list. Number one, if the list is empty, and number two, if the head node element or data is larger than the new data. So to maintain the order in ascending, to maintain ascending order, insert at front of list. Okay, next we need a remove function, public void remove empty data, remove element from the list. So this method does not require to maintain the order of the list, because it can remove any element from the front, from the middle of the list, or from the end of the list. The order is automatically maintained within the list. So next function, public int size, return the number of elements in the list, and next we need, let's say, public boolean is empty function to check if the list is empty, indicate empty list. And the final function we need is print function. Print the list. Okay guys, now let's start with, we need to add one more field, count of elements, private int count. Let's initialize it to 0, though it is automatically initialize all the intrinsic values like int, float, double are automatically initialized in Java to their default values. So count is equal to 0. Good practice is initialize it. Okay, let's begin with some other functions. So first is empty, return head is equal to null, and size simply return the count. And print function, check if empty. If this start is empty, so simply print the list is empty and return from here. Now loop till the end of the linked list. So we need node current is equal to head, and we loop till current becomes null. So we print the data percentage s, and let's print it. Okay, so we print the first value, percentage s, and current dot get data dot toString. Okay, now move one step forward. Current is equal to current dot get next. Okay, now we print with comma current dot get data and navigate. Current is equal to current dot get next. Okay, now s out this, so it will print something like this: value 1, value 2, value 3, value 4, and 5 etc. Okay, this is the way basically Java internal linked list and other data structures display their values. Okay, now the add first function. Okay, so create new node, and data. Okay, if case 1, if empty, if this dot is empty. So we will do store the value to the head and increase, let's leave it. And second case, case 2, insert before head. So what we will do, set the next reference to the current head, new dot set next to the head, and then assign to new node to the head, and that's it. Increase the count plus plus. Instead of placing current here, count increment statement here and again here. This is redundancy. Must keep track of it. There should be minimum redundant code within the application. Okay, now this is our major function. So first of all, check if we need to insert before head or front of the list, case 1 and case 2 as we discussed here. So what we will do, we will check if this dot is empty, if this list is empty, or data dot compare to head dot get data. So we will call the this dot add first and pass data. Okay, so we start with check empty list. If this dot is empty, simply print a message, this list is empty, and return from here. And let's call it case 1. And case 2 is remove from the front if head dot get data dot equals data. So we simply set the next node to the head node, head dot get next. That's it. And we reduce and return. Now here we have to find the position of the node to remove if it exists. So declare supporting handlers. So node t current and pre is equal to null and current is equal to head. Okay, now move while current is not equal to null. So what we will do, check here, if current dot get data dot equals data. So what we will do here, pre dot set next is equal to current dot get next. And we reduce count and exit the loop. Here we update the references. So store current to the pre and move current to the next, get next. That's it. We are done. Okay. All the functions are done. Okay, let's test it now. So integer list. Okay, so ordered list integer int list is equal to new ordered list. Okay, insert, let's say int list dot add, let's say 5, and let's put some values, 2, 9, 11. Okay, this should be like this, and here like, and 2, 5, and this should be 2, 5 and 9, and let's put 11. So it will become 2, 5, 9, 11, and int list dot add, and let's say 5, let's say 4. So if we insert 4 here, it should be 2, 4, 5, 9 and 11. Let's print them. Int list dot print and copy paste. And last print. Okay, next we will remove. Let's test this one first. Okay, let's run it. Okay, 5 is okay, 2 and 5 is okay, 2, 5, 9 is okay, 2, 5, 9 and 11 is okay, 2, 5, 9, 4, this is not in order. So we must have done something wrong. So let's check. Okay, this is our function. Okay, we have missed one thing here. We should be comparing the next node, get next and get data. Now I think the order will be good. Let's run it. Yes, our order is good. Now the remove function. Int list dot remove. Let's say we remove from the middle. So list should be 2, 4, 9 and 11, and let's copy. Okay, so remove, let's say last node, so 11 should go and next remove, let's say 4. So 4 should go, and remove the first node. So we should left with 9 only, and remove 9 should be an empty list. 9, and let's test it. Okay, that's it. List 2, 5, 9, 11. Sorry, this is over. 1, 2, 3. This is our list. 2, 4, 9, 11. After removing 5, and 2, 4, 2, 4, 9 after removing 11, and 2, 9 after removing 4, and 9 after removing 2, and this is empty list after removing 9. That's it, guys. This is our generic singly linked list, and it is ordered. It maintains ascending order of the linked list, and we can remove any element from the front, from the middle, and at the end of the linked list. It will still maintain the order. Similarly, we can insert any element in the front, in the middle, in the end of the linked list, and it will maintain the order of the linked list. And this is a ascending order, and this parameter help us use it as a parameter for any object, custom class or the built-in class that implements comparable function or comparable interface. This order linked list is good to go with it. Thank you, guys. And if you have not already subscribed to my channel, please subscribe and help promote the content. Keep watching my videos, and see you in the next video. Thank you. Have a good day.